Welcome to the second part of the video on polar coordinates. In the first part, we defined polar coordinate and we related XY coordinate, meaning Cartesian coordinate, to polar coordinate, and we did some simple problems. So if you need to refresh your memory, I would request you to see the previous video. The link is given in the description box. So here in this video, we'll be doing basically two category problems. The first one will be representation of a point in different ways, and the second thing will be conversion. Okay, so let's begin with the first category problem, representation of a point. Representation in different ways. So we need to remember two basic things, basic facts. So let's say we have this first rule. The ordered pair r comma theta, and if I have another ordered pair, let's say r theta plus 2n pi, these two ordered pairs represent the same point in the polar coordinate. And the second thing, r theta, the point r theta and negative r comma theta plus 2n plus 1 pi, these two ordered pairs also represent the same point. So here is the first category problems. We will do these two kinds examples. Okay, so if I have a point, let's say I have this point, the point A, and its coordinate is 3, 7 pi over 6. For simplicity, let's say not 7 pi, let's say just pi over 6. So in that case, if I want to sketch this point in polar coordinate, let's say I have my coordinate here, coordinate system. I want to sketch this point 3 pi over 6 in this coordinate system. So 3 units apart from the origin, 1, 2, 3, and the rotation is pi over 6. Pi over 6 is here. So here is my point A. Now if I add 2n pi with the given angle pi over 6 for n equals to any integers, meaning n could take value 0, plus minus 1, plus minus 2, so on and so forth. So if n equals to, let's say, positive 1, then the angle 2 times 1 times pi plus pi over 6, this equals 6 times 2 pi over 6 pi plus pi over 6. We get 12 pi over 6 plus pi over 6. So we get 13 pi over 6. So the point A, and if I have another point, let's say another point B with the parameter R3 and the angle is 13 pi over 6, they will represent the same point. So how do I know that? Well, pi over 6, it's 30 degree. 30 degree is being multiplied by 13. So the angle is 390 degree. That means if I finish a complete rotation of 360 degree, I will end up here, and then another 30 degree. If I move another 30 degree, I will stop here. So point A and point B, they both represent the same point. So this is the example of the first rule of the representation r theta and r comma theta plus 2 and pi represent the same point in the polar coordinate system. So if you substitute n equals to any negative integer, let's say I put n equals to -1, in that case I get angle pi over 6 minus 2 pi, and I can rewrite this as pi over 6 minus 12 pi over 6 equals to -11 pi over 6. So if I think here another point, let's say another point C, and its coordinate is 3 comma -11 pi over 6. In this case, 11 pi over 6, 30 degree is pi over 6, and if we multiply this by 11, we get 330 degree, and we got a negative sign in the beginning, so we'll move clockwise direction, meaning we'll move this direction. Since it's 3 units from the center, so first we'll come to 3 units apart from the center, we'll stop here, and then we'll start moving in this direction, and eventually we'll end up here. So this is the point C. So this is actually point C, point A, and also point B. So that's the interpretation of the first kind. And for second kind, let's say I have a point 2 comma pi over 3. I have this point. I'm saying this point is, let's say, D, and I want to find another representation of the same point. How do I do that? Well, if I write, if I do add or subtract, if you see here the formula, we have to have -r, and we have to add odd multiple of pi. So n could take any value. I'm gonna put n equals to 0. Let's see what that gives. So I have pi over 3, and I'm adding just simple pi. So in that case, if I make common denominator 3, I get 4 pi over 3, and if I write another notation, -2 comma 4 pi over 3. Both of these two points represent the same point. So let's draw the first one, 2 comma pi over 3. Let's say, or the polar coordinate system, whatever you say, and I have this origin. So +2, let's say this is 1, 2, 3, 4, and I'm saying +2 is here, and pi over 3, it should be somewhere here, not unit circle. So this is distance 1 from the center, this is 2, this is 3, and so on and so forth. So first let's draw the point D, 2 comma pi over 3, it should be somewhere here. So this is point D. Now -2, if I want to sketch the second point, initially I should skip the negative sign. I will find the point 2 comma 4 pi over 3. So 4 pi over 3, as pi over 3 is 60 degree times 4, you get 240 degree. 240 degree, it's greater than 180 degrees, so it should be somewhere in the third quadrant, and it's also less than 270 degrees, so definitely it's in the third quadrant. So since it's -2, if this is distance 1, this is distance 2, we are here with 2 comma this point. Let's say I'm saying this point, it's E, no, it's not E, it's F, it's 2 comma 4 pi over 3. Since we have negative sign to our actual point, we are no longer here, we'll go back to this point. So literally D and E both are at the same point. Okay, so our next category problem is the conversion problem. Conversion. By conversion we mean that we'll convert the coordinate system from polar coordinate to rectangular and rectangular to polar, vice versa. Meaning, if I have a coordinate like this r theta, I want to represent this as x, y, or if I have a coordinate that's given in xy format, I want to convert that back into r theta. We have already done this in our first part of this video series. Let's do a quick recap of that theory, of that information. Let's say I have a xy coordinate like this. Let's say this is the x-axis, this is the x-axis, center, and the y-axis, and I have a point P here. I'm saying the coordinate of this point P is xy, meaning the point P is x unit apart from the y unit, y-axis, and it is y unit apart from the x-axis, and from the center the distance is r. So the relationship between x, y, and r, and if we have an angle theta here, so the relationships are given as follows: x equals to r cosine theta and y equals to r sine theta. So if we are given r and theta, like if we want to convert from polar to rectangular, we'll use this pair of formulas. This for from polar to Cartesian. Now if we want to convert back from Cartesian to polar coordinate, we need another pair of information, and that is x squared plus y squared equals to r squared, and the other one is tan theta equals to y over x. This relation comes from the Pythagorean theorem, if you want to relate from that. And tan theta, we got this dividing the second equation. If I say this is the second equation and this is the first equation, dividing the second equation by the first equation, we can get this tan theta equals to y over x. Okay, let's start some example. Let's say I have this point 3 comma 5 pi over 3, and the question says convert the point in polar coordinate to Cartesian coordinate. So this is the question: convert the point in polar coordinate, meaning this point is polar coordinate. This point P, if I say this is P is in polar coordinate, we have to convert this in Cartesian. So here r equals to 3 and theta equals to 5 pi over 3. So to get the converted value, we use formula 1 and 2 here. So we write x equals to r cosine theta and y equals to r sine theta, and then we substitute the values: 3 cosine 5 pi over 3 and y equals to 3 sine 5 pi over 3. Now we have to substitute the value of cosine 5 pi over 3, and the value of cosine 5 pi over 3 is 1/2. 3 times 1/2, and this is the value of x, and y equals to the value of sine 5 pi over 3 is negative root 3 over 2. So 3 times negative root 3 over 2. So if I want to write my answer as an ordered pair, I can write xy equals to 3 over 2 comma negative 3 root 3 all over 2. So that's the conversion from polar to Cartesian. Now let's do the opposite. Let's say we have a point B, negative 3 root 2 comma positive 3 root 2, and we want to convert these to polar coordinate. That means the point B here, we're given x equals to 3 root 2 and y equals to positive, x equals to negative 3 root 2, y equals to positive 3 root 2. So if I draw the coordinate system, Cartesian coordinate system, I can see my x value is negative and y value is positive, so the point should be somewhere here, approximately somewhere here. So this is point B, and negative 3 over 3 comma root 2 comma positive 3 comma root 2. So this is the Cartesian system. The point is given. Now to convert this point in polar coordinate, we need to know the distance from the origin, from the point O to point B. This is gonna be our r, and we also need to know the amount of rotation, theta. We need to find these two parameters in order to get the point in polar coordinate. So we're going to use the formula that we listed here. If I say this is formula 3 and this is formula 4, we have to use this formula 3 and 4. The first one, r squared equals to x squared plus y squared, and then we just substitute the values of x and y here. So negative 3 root 2 squared plus 3 positive root 2 squared, we get 9 times 2 plus 9 times 2, 18 plus 18 equals to 36. So then r equals to plus minus 6. That's the value of r. We'll consider which sign we'll pick at the end. Now we have to find the value of tan theta, which is defined in formula 4. Tan theta equals to y over x. So y is positive 3 root 2, and x is negative 3 root 2, and we get negative 1. That means tan theta equals to negative 1. We know tangent is negative either in second quadrant or in the fourth quadrant, and the point is already in the second quadrant, so we also know the angle. In first quadrant, tan theta, if I have an angle alpha in the first quadrant and that equals to tan alpha equals to 1, then I can directly say this alpha is 45 degree. This is alpha 45 degree, or pi over 4. Now if I start counting as a unit of pi over 4, this is 1 pi over 4, 2 pi over 4, and 3 pi over 4, I will end up here at the middle point. Since the x and y are equal, so the line will pass through the origin, equal distance from both an x and y. The angle here is 3 pi over 4. So I'll write theta equals to tan inverse negative 1, which is equal to 3 pi over 4. So finally, when we'll write the answer. We have to pick whether r is positive or negative. So we can pick r equals to positive value. We can also pick r equals to negative value. In that case, we have to rewrite the angle. So for simplicity, we'll write r equals to 6 and theta equals to 3 pi over 4. So as an ordered pair, we can write 6 comma 3 pi over 4. That's it. So we have one more topic left, that is conversion of equation, but we'll discuss that in the next video. Thank you.